Hello everyone, welcome to the learning session on analog communication. In today's video, we are going to learn about classification of communication systems. In this video, we will discuss this classification one by one using simple explanation and real-life examples so that the concepts are easier to understand. So, without further ado, let's get started. The first classification is based on the communication channel and the behavior of the communication system itself. This classification helps us understand how a communication system responds when transmitting signal from the transmitter to the receiver. There are three categories that we will discuss. First is the linear and nonlinear systems, and then time variant and time varying systems, and last is bandwidth limited and power limited systems. Let's begin with the first one. First, let's discuss the linear system. A communication system is called linear when the output signal changes proportionally to the input signal. Simply put, if the input signal becomes twice as large, the output signal will also become twice as large without changing its original waveform. In other words, the communication channel doesn't significantly alter the signal. A common example of a linear system is a wired telephone. Because the signal travels through a stable cable, the channel introduces very little distortion. As a result, the transmitted signal remains almost identical to the original signal. This makes wire communication one of the simplest examples of a linear communication system. Now, let's move on to the nonlinear system. Unlike a linear system, a nonlinear system doesn't produce an output that is directly proportional to its input. As the input signal becomes stronger, the communication equipment may introduce distortion, causing the output signal to change its shapes. Satellite communication is one of the best examples of a nonlinear system. Before transmitting signal back to Earth, satellites use high-power amplifiers to increase the signal strength. However, when these amplifiers operate close to their maximum capacity, they may distort the signal. Because of this behavior, satellite communication is classified as a nonlinear communication system. The next classification is based on whether the system changes over time. A time-invariant system has characteristics that remain constant over time. This means that if the same signal is transmitted today, tomorrow, or next week, the system will produce nearly the same output provided that the communication channel remains in good condition. A good example is an optical fiber communication system. Since optical fiber provides a very stable transmission medium, its performance remains consistent over time. On the other hand, a time-varying system has characteristics that change over time. Its performance depends on environmental conditions such as user movement, buildings, trees, weather, and other obstacles. Mobile communication is a perfect example. When you move from one place to another, your phone signal may become stronger or weaker. This happens because the communication channel continuously changes as the surrounding environment changes. The last classification in this section is based on the main limitation of the communication system. The first one is the bandwidth limited system. In this type of system, the available bandwidth is the main constraint. Only signal within a certain frequency range can be transmitted effectively. A wired telephone system is a good example because it only requires a relatively narrow bandwidth for voice communication. In contrast, a power-limited system is mainly restricted by the available transmission power. Satellite communication is one example. Since satellites are located thousands of kilometers above the Earth's surface, the received signals becomes extremely weak. Therefore, communication systems must use high-gain antennas and powerful amplifiers to maintain reliable communication. Now that we have learned about the characteristics of communication systems, let's move on to the second classification. This classification is based on the mode of transmission, or in the other words, the direction in which information flows between the transmitter and the receiver. There are three transmission modes that we need to understand: simplex, half duplex, and full duplex. Although they all involve communication, the way information is exchanged is quite different in each mode. Let's start with the first one, the simplex mode. A simplex communication systems allow information to travel in only one direction. In this mode, one device always acts as the transmitter, while the other device only acts the receiver. Since the receiver cannot send information back, there is no feedback or response through the same communication channel. One of the easiest examples is radio broadcasting. A radio station continuously transmits audio signals to thousands or even millions of listeners. However, the listeners cannot use their radio to send signals back to the broadcasting station. Therefore, in a simplex communication systems, information always flows in only one direction. The first two-way communication The first two-way communication mode is called half duplex. A half duplex communication systems allows information to flow in both directions but not at the same time. This means both users can send and receive information, but they must take turns. When one person is transmitting, the other person must wait until the transmission is finished before replying. A common example is a walkie-talkie. Imagine that two security officers are communicating using walkie-talkies. When the first officer when the first officer presses to the push to talk button and starts speaking, the second officers can only listen. Only after the first officer finishes speaking can the second officer press the button and respond. These alternating communications prevents both users from transmitting simultaneously. Although half-duplex communication is lower than full-duplex communication, it is still widely used because it is simple, reliable, and efficient for many applications such as security, military operation, and emergency communication. A full duplex communication system allows both users to transmit and receive information simultaneously. In other words, both communication devices work as transmitter and receivers at the same time. This creates a much more natural and interactive conversation because neither user has to wait before speaking. The best example is a mobile phone call. During a phone conversation, you can speak while listening to the other person at exactly the same time. This simultaneous communication makes conversation faster, smoother, and more efficient. Today, full duplex communication is widely used in mobile networks, video conferencing, internet calls, and many other modern communication systems. So far, we have learned how communication systems are classified based on their characteristics and transmission modes. Now, let's move on to another important classification, which is based on of the type of the signal used to carry information. In general, communication systems are divided into analog communication and digital communication. Although both systems are designed to transmit information from a transmitter to a receiver, they differ significantly in the way the information is represented and processed. Let's begin with analog communication. Analog communication uses continuous signals to represent information. This means that the signal changes smoothly over time following the original information without interruption. For example, when we speak into a microphone, our voice naturally produces a continuous waveform. If this waveform is transmitted directly, it becomes an analog signal. Several modulation techniques belong to analog communication, including amplitude modulation, commonly known as AM, and then frequency modulation, or FM, and then phase modulation. And the next is pulse amplitude modulation, and then pulse width modulation, and pulse position modulation. Each technique modifies a different characteristic of the carrier signal in order to transmit information efficiently. One of the main advantages of analog communication is its simplicity. The circuits required to build analog communication systems are generally less complex, making them easier and less expensive to implement. Another advantage is that analog communication often requires relatively small bandwidth for certain applications, such as voice transmission. In addition, multiplexing techniques can be implemented quite easily in analog communication by assigning different carrier frequencies to different signals. For many years, this advantage made analog communication the dominant technology around the world. However, analog communication also has several limitations. The biggest disadvantage is its sensitivity to noise. As the signal travels through the communication channel, unwanted electrical interference may be added to the original signal. Unlike digital communication, this noise can be completely removed, resulting in lower signal quality. Another limitation is that analog systems cannot effectively use repeaters to regenerate the original signal. Instead, repeaters simply amplify both the signals and the noise together. In addition, analog communication provides very limited security because it doesn't naturally support encryption techniques. As a result, analog signals are much easier to intercept than digital signals. Unlike analog communication, digital communication represents information using binary digits or bits consisting of 0 and 1s. Before transmission, analog information such as voice, image, or video is converted into digital data through an analog to digital conversion process. Several digital communication techniques include pulse code modulation, delta modulation, and digital modulation methods such as amplitude shift keying, frequency shift keying, phase shift keying, and quadrature phase shift keying. These techniques allow digital systems to transmit information accurately over long distances. So far, we have discussed the characteristics of communication systems, their transmission modes, and the types of the signal they use. Now, let's move on to the final classification, which is based on how the signals is transmitted from the transmitter to the receiver. There are two main types of signal transmission. The first is baseband transmission and bandpass transmission. Although both methods are used to deliver information, they work in different ways and are designed for different communication needs. Let's begin with baseband transmission. A baseband transmission sends the original information signal directly through the communication channel without using a carrier signal. In other words, the signal is transmitted in its original form without being shifted to a higher frequency. The frequency spectrum of a baseband signal starts from 0 Hz and extends up to the highest frequency contained in the message signal. Because the signal is transmitted directly, the communication systems become simpler and doesn't require a modulation process. However, baseband signals generally have relatively low energy. As a result, they cannot travel over very long distances without experiencing significant attenuation. For this reason, passband transmission is mainly used in short-distance communication systems such as Ethernet or local area network, commonly known as LAN. Unlike baseband transmission, bandpass transmission uses a high-frequency carrier signal to transmit information. Before transmission, the original message signal is combined with a carrier through a process called modulation. This process shifts the signals from the baseband frequency range to a much higher frequency range. Why is this important? A high frequency carrier has much greater energy and can travel much longer distances. It also allows signal to be transmitted efficiently through antennas and wireless communication channels. This is why modulation is an essential part of most long-distance communication systems. Examples of bandpass transmission include radio broadcasting, television broadcasting, satellite communication, Wi-Fi, and mobile communication networks. Without modulation, these communication systems will not be able to transmit information over large distance efficiently. Now, let's summarize everything we have learned in this lesson. Communication systems can be classified in several different ways. First, based on their channel characteristics, they can be classified as linear or non-linear systems, and then time-variant or time-varying systems, and bandwidth-limited or power-limited systems. Second, based on the transmission mode, communication systems can operate in simplex, half-duplex, and full-duplex mode. Third, based on the signal type, communication systems are divided into analog communication and digital communication. Finally, based on the transmission type, communication systems use either baseband transmission and bandpass transmission. Understanding this classification provides a strong foundation for learning more advanced topics in analog and digital communication. Thank you for watching this video. I hope this lesson has helped you better understand the classification of communication systems. I'm Syifa Auriga. See you in the next learning session.